Well, good evening. Come on, my voice is louder than I do. All right. Okay. Okay, let's try it again. Good evening. There we go. Now we know. My name is Mohsen Janatpur. I am professor of math, physics, and astronomy. I clean the floor, but also run astronomy program. And one thing I want to tell you, I feel so good today. We had an awesome group. The whole day has been super success. 2 days ago, I had a meeting with some of my astronomer friends. Ken is sitting right there, and Ed is sitting there. And we were talking about the weather is going to be so bad, what we're going to do. And I said, you guys don't understand. My name is Janatpur. Janatpur means son of heaven. That means I have another connection, okay? And the weather turned out right. So because of that, we are going to have our stargazing on time at 9:15. After this class, you can go there. Do it. Yeah. So you're going to have a good time. Now, before I start, I want to thank my students, or all students, and the volunteers. If you're in this room, stand up, okay? Okay? All the volunteers stand up. They are the ones that actually get all the credits. They did amazing job. And the Family Science Day would not have been successful if it wasn't because of they. We had tremendous crowd. In fact, in some of the workshops, we had over 300 people. And yet, they were all so expertly and professionally handled the crowd, the kids, and everything. So please give them another hand. It was awesome. Also, I want to acknowledge one more person who has been really supporting me in all this endeavor. Chris, are you here? Chris Walker, are you here? So forget about it. He helped me a lot, actually, I should tell you. He is the new dean of our division, and he did a lot of help giving me support to do this. Now, the good part of it for getting our speaker tonight, the best I can say, is serendipity. It was a lucky thing. A long time ago, I was talking to our keynote speaker, a long time ago when some of you were not even born. I got fascinated with the Apollo 11 project because that was part of my job too. And since then, I have always been fascinated, not so much with the moon itself, but with the projects that gets us to the moon. And I've been very fascinated with that. And a few years ago, right before COVID stuff came around, I had one of our dear friends, Dr. Daniel Day, Brian Day. He was our guest speaker here. So I called him again and said, Brian, could you be my guest speaker again for this event? Brian said, you know what, Mohsen, I'd love to do that, but I can't because I have to be in Texas. I said, oh, shoot, my wife really liked your talk. He said, I tell you what, how about my boss? Would you like? I said, yes, let's go for that. Yeah, no way I would miss. It couldn't be better than that. Then I talked to Greg and I said, God, my audience is going to be very, very lucky to have you. And send me a short bio. And normally, you guys know probably, some of you have me, I never read anything on the stage. And then when I looked at his, I said, wait a minute, I cannot say all of this and remember all of this. And I'm not going to read all of it because then that would take all of my his talk. So this guy is the director of the Solar System Exploration Research Virtual Institute. Whew. Okay? SSERVI. I cannot even pronounce that, okay? And that is the start, okay? He was the Associate Director for Strategic Planning in Ames Research Center Science. Well, co-founder of the NASA Ames portal. Should I go on? Well, let me tell you one more at least. He developed the science of astrobiology and NASA's Astrobiology Institute. I think I should have stopped there. All right? It is my honor and privilege to introduce to you Mr. Greg Schmidt. Thank you.
Thanks, Listen. Can you hear me? All right. It's my honor to be here and talk with all of you and share some insights, share some fun stories with NASA. How many NASA geeks are out there? Yeah. Yep. I've been one. My mom found something that I wrote when I was 6 years old that gave me goosebumps, that said, when I grow up, I want to work for NASA. The few drawings of rockets and stuff. This was around 1965 or so, and I got really, really lucky and have just had this incredibly blessed time, blessed career, doing super cool, fun things. And so I want to share that with you. And I gave a similar talk at UC Berkeley a few weeks ago and decided that I got so many questions about other stuff that NASA was doing beyond just the moon that I put in a few things there, including earth sciences, which was a bow to my wife. She's an earth scientist at NASA Ames, a program manager, and the way we say it when we meet people is I look up and she looks down. And she also says that she's more grounded than I am, and that's also true. Anyway, I want to ask a question, just raise of hands. How many people here were alive and remember the Apollo 11 landing? Yeah, that's a fair number, actually. And there are an awful lot of people I can see that weren't even close to being born yet. And so one of the things that I want to talk about tonight is how inspiring that was, I think, not just for our nation, but for the whole world. My institute has partnerships with 11 different nations. We're working on about 5 more. And people tell me stories about this, about where they were, when Apollo 11 landed on the moon and the effect that it had on them. So, when Neil Armstrong talked about doing this for the whole world, he really meant it, and he might not have even seen how profound an effect that would have. So, what I'll be talking about tonight is a little bit of a reflection on Apollo, some things about what we're doing now with regards to the moon, and my institute is really focused on the moon right now. We sponsor a wide variety of research on, of, and about, and from the moon, and it's connected with NASA's Human Exploration Enterprise. And so what we do is try to do science that's going to inform people going to the moon. So we do a little bit of a fast forward from that first image to this image right here. The last moonwalk was a long time ago, and one of the astronauts, Gene Cernan and Harrison Jack Schmidt, were the two that walked on the moon. Jack Schmidt is actually a good friend of mine. He's still around. He is still an accomplished scientist, and he's the only geologist, only scientist to have ever put his footsteps on the moon. And he's at science conferences all the time, and we gave him a few years ago gave him our institute's highest honor, the Shoemaker medal, for all the amazing things that he has done and continues to do. So the moon was and is important for so many reasons. I think that this, being a similar image to one that you've all seen from Apollo 8, is broadly thought of as the image that launched the environmental movement. So I find it really interesting that we went all the way out there only to learn about here, and to increase our awareness. And so many of the astronauts have said how there's this very thin atmosphere, this thin biosphere, and from that perspective, they could see it. This is I don't remember Carl Sagan's quote about this, but this is where everything has happened in human history and the history of life, this very precious blue marble that we call home. And so what we're doing is trying to create a path forward that will give us new homes eventually in the future. And some of the younger people in the audience, I see some pretty young ones there, you guys are going to be the ones that are going to be going to Mars potentially. There's quite a bright future for all of us, I think. It was an incredible thing what we did back. I say we. I was in elementary school when this was going on. But anyway, an incredible thing what this nation did to put these men on the moon, working together. Our path forward is a little bit of a different one, and it's one that I really like, and I think it's appropriate for our time right now. But one thing to keep in mind is that this is a quote from that my good friend Andy Chaikin, who's the world's foremost Apollo historian, got from one of the people that he interviewed. He's the one that wrote the book that resulted in that HBO series From Earth to the Moon. How many folks have seen that? If you haven't seen it, go for it. It is just absolutely an incredible story, and you're going to get far more than my talk about what it took to do this. And Andy interviewed so many people for this, including all of the astronauts but one who had passed away by the time that he did his book, but Neil Armstrong, Buzz Aldrin, all of them. So it was a difficult journey, but we're doing it a little bit differently now in some important ways that I'm going to be talking about. What did we find when we went to the moon? A lot of people don't know, about the importance, for instance, of the lunar samples. We in my field, we call them the gift that keeps on giving. We are still learning from the samples that were collected in 1969, 70, 71, 72. That's it. That short period of time. We got these samples that are curated at the Johnson Space Center. The famous one of Houston, we have a problem from Apollo 13. We are still getting amazing science from those samples. They have served as Rosetta Stones to tell us about so many things, not just about the moon, but our whole solar system. So, for instance, they have told us there was a hypothesis that evolved from the lunar samples about the formation of the moon. This is something that before we went to the moon, we had no idea how it actually happened. There were some thoughts, but they were unsupported. And what we now are pretty sure happened is that there was a giant planet called Theia, which collided with the very early Earth. And you can imagine how violent of a collision that would have been. that created the debris cloud that coalesced and became the moon. We found that out from the samples, from these samples that we've gotten, which I think is pretty incredible, an amazing legacy. I showed you the other picture of the Earth from the moon, but there was actually an even earlier one, and some of you in my age group may remember the picture on top, or pictures like that where there were stripes. This to me is an amazing testament on what people could do. So they sent a series of 5 different orbiters to the moon ahead of the Apollo landings. These were robotic orbiters, and they were based on defense technology. And of course, if you remember, we were right in the middle of this huge Cold War, and so there was a lot of money going into this on the defense side. And what they did is they actually had film, you know, with that old stuff that the younger generation knows nothing about right now, thank goodness. and that it was developed on board these robotic spacecraft. It was scanned in a process that's similar to today's fax machines. We shouldn't even say today's, because who uses a fax machine anymore, right? And the images were then sent to Earth. That top image is what you see, what was sent back there, and from those images, we decided on Mare Tranquillitatis, for instance, as the Apollo 11 landing site. Now, what we have done, this is kind of cool, and I sponsored this project back in 2008. Is we took those images, we took the original data, we had these giant machines that, and these 2-inch tapes that these machines read, and there was an article on the front page of the LA Times about what we did. I got interviewed for that many years ago. And what we did is we got that data, we smoothed it out, and so now we're able to tell what the moon looked like, you know, back 50, almost 60 years ago. And you might think, well, doesn't it look the same as now? Pretty much. But what we're able to tell is that there have been impacts since then. You know, the meteorites that hit the moon and caused the craters, they haven't stopped. And so we're able to find new, fresh craters, you know, which is another part of the legacy that Apollo has given us. So we wanted to go back after Apollo, and we've had 3 honest-to-goodness attempts, the first being in the Bush Senior administration, and that didn't get very far at all. And the Bush Junior administration started the Constellation program, which unfortunately was canceled. But then the previous administration started Artemis, and that's the one that has stuck. And let's all keep our fingers crossed, given all the stuff going on with government funding right now. But it looks like it's going forward, and it looks like we're going to be doing landings on the moon in the relatively near future. You probably saw the Artemis 1 mission right around a year ago, I guess it was. That was an uncrewed mission. It was flown robotically, but with the same spacecraft that's going to be used for human missions. And the Artemis 2 crew has been set, and I don't know how many of you have seen the crew. There are 4 people that are going to be flying to the moon. This is going to be a mission that's similar in a lot of ways to the Apollo 8 mission. So they're going to go on the far side of the moon. The orbit is pretty different, but anyway, and so this is going to be the first time humans have been around the moon since the early 1970s, as I mentioned. And then I'll be showing you a diagram of this, but after that comes Artemis 3. When exactly that's going to happen, we're not sure, but it's targeted for late 2025. I think realistically it's going to be the following year, perhaps even the year after that. But quite honestly, looking at the past, that's pretty darn soon, and what could be more exciting? So, so the Artemis era has begun, and what you see here is the first landing vehicle that was chosen by a competitive selection. This is the SpaceX Starship. Now, I mentioned a little bit earlier that we're doing things differently now than we did in Apollo. One of the differences is that we don't have the money. We don't have the national resources that we did back then. Back then, Apollo was really about the the U.S. and the Soviet Union. It was a race to see who could get there first. And NASA's budget peaked at, I think it was between 4 and 5% of the entire U.S. budget, including defense and everything else. Our budget right now, NASA's budget right now, is 0.5%. So basically, relative to the U.S. budget, about 10 times less. And so you can't go to the moon, again, with that kind of money. And so we had to be clever. And so thank goodness that we have these new companies that are like SpaceX and Blue Origin and quite a few others that we work with at my institute and NASA headquarters works with that have these new capabilities. And so this first lander is going to be built by SpaceX. Now, you might have seen, that there was a test of this. It launched from Texas. Let's just say I wouldn't call it an entirely successful test. It blew up, after it left the pad. But I think that with time we'll figure things out and figure out what went wrong and do it again. And that's one advantage of having this money coming from industry to invest in this versus the way we did it before. And we now have Blue Origin as well that's been selected as the second provider of a lander. This looks like something from out of a 1950s science fiction film, right? A little bit. The Blue Origin lander looks a lot more like the Apollo lander did. One perspective that I like to share, looking towards the future, we're going to the moon this time, not just for what we at NASA call flags and footprints, but we're going there to try to create a sustainable future on the moon. And the idea being, and my friend Andy Chaikin was a guest speaker at my institute's conference this last summer, and he said, imagine looking up with the telescopes that you'll be looking through after my talk here, and seeing some faint lights, on the shadowed part of the moon that you can see, and thinking that there's a human settlement there, and how exciting will that be? I think that it's really important that to realize that space in general, and Apollo in particular, has produced lasting changes in our perspective about things. This is a photo of a very dear friend of mine who passed away. He was a Nobel laureate. He was actually the person that discovered the hepatitis B virus, and that was what his Nobel Prize was for, and then later developed the vaccine for it. He was said to have saved more people from cancer than anyone who ever lived, and this is a conversation that he and I often had about the insights from space. He was our distinguished scientist at my institute, and he was also the founding director of the NASA Astrobiology Institute. And then we were able to engage with others as well, other thinkers as well. Alvin Toffler might be a familiar name to some of you, who wrote Future Shock. And I think that his quote there is really important, and I'll read it. The illiterate of the 21st century will not be those who can't read and write, but those who cannot learn, unlearn, and and relearn at an increasingly fast pace. So one of the other things I mentioned, I talked about commercial. I'll talk a little more about it in a bit. But one of the other things is that space is now a multinational effort. I mentioned that our institute has 11 partners throughout the world, from the Far East to developing partnerships in Africa and Mexico. We have a number of European partners, Canada, et cetera. And these nations are doing pretty amazing things. Some of them have their own lunar missions, and I'll talk about that in a little bit. And we have something at NASA called the Artemis Accords, which are agreements that nations enter into with the United States in order so that they can contribute to this great journey. And so thank goodness, it's no longer the US on one side and the Soviet Union on the other. It's a lot of nations working together. That isn't completely true, but it's largely the case now, and I couldn't be prouder. And one example of what these nations are doing is, I'm sure a lot of you have seen Chandrayaan-3, the Indian lander that went to the moon recently. They just lost contact with it, but that was expected. But it did some amazing science, and we're planning a workshop between my institute and their institute that put this mission together early next year to talk about their scientific results and talk about a path forward. The Japanese, you might have seen recently, just launched a lunar lander mission. So this is something that the bar is low enough that a lot of countries are now able to do this who weren't able to before. I'm not going to go into detail on this other than to say, if you take a look at this diagram, the very fine lines around each of these bodies, so you have Mars, the moon, Jupiter, Saturn, et cetera. Those are the missions that have gone there. There's a lot of missions, a lot of missions. I think it was Carl Sagan also who said that there will only be one generation that will be the one that at the start of it, these objects were points of light or things that we look at in a telescope. Now they're actual worlds that we've explored. In some cases, like Mars, we've landed on them. So we live in a really, really privileged time right now, all of us, to be part of this journey. This shows shows a little bit closer all international landed moon missions. This diagram isn't even complete. There's a few more recent ones that aren't included, and missions to Mars as well. And you have a lot of countries. The United Arab Emirates had a highly successful orbital mission to Mars. So a lot of people are joining in with us, which I think makes it so much better. We, as I mentioned, have a number of international partners at my institute. You can see the list of them going all over the world. As I mentioned, I'm actually going to be going to Africa a week from tomorrow with my wife, who's also with NASA. I call these Mr. Cindy Schmidt trips because it's a work trip for her, and I'm the plus one. But I'm actually going to be meeting with a delegation from South Africa, taking a look at a potential partnership with them. And I think that one of the things that I personally find so exciting is when you give talks to groups of people like you guys right now, students, whatever, but it's in a country that isn't at our economic level. It can really, really inspire them, just like it does with all of us. And so this is, for me, a big priority for the rest of my time with NASA to bring more nations into this great journey taking with us together. We have One thing that we do every year is the European Lunar Symposium. This is something that we started. It's now the biggest meeting, the biggest moon-focused meeting in Europe. It was just in Italy, 2 or 3 months ago. It's going to be in Scotland next year. If any of you are in the mood for some haggis, come join us. I want to talk a little bit more about commercialization now, which is really key to our future. And I've talked a little bit about Artemis, but one of the things that is extremely cool that's going on right now was actually started by Google. Google had something called the Google Lunar X Prize. Does that sound familiar to anyone? No, it was a while ago. Basically, Google offered 35, 40 million, something, I forget the exact number, to the first company that could land a rover on the moon and then transmit back images. And so what that did is it started kind of a gold rush of small companies. And we've worked with some of these companies. Some of them have risen and folded. Some of them, on the other hand, have done really well. Intuitive Machines, Astrobotic, some of the others. What NASA has done with this, the Google Lunar X Prize expired. No one did it in the amount of time that they allotted, but the companies kept on going because they saw commercial promise out there. And so what we at NASA did, I was involved in the very early stages of this, is decided, if we can get these companies to carry our stuff, then all we have to do, we don't have to build spacecraft, we just buy the ride, And so it's much more like paying for an airline ticket when you want to go somewhere rather than having to buy the airplane. And so we have this program that has been started. A good friend of mine at NASA headquarters is running this, and we're going to have the first private missions to the moon. Keep our fingers crossed that they land successfully. It's not an easy job. The first one is going to be in just a couple of months in November. So be watching your news sources. It's going to be pretty exciting. I expect fully that not all of them will be successful, but I'm hoping that some are. And what that's going to do is really change what we do, the way we do science on these bodies, and it dramatically reduces the cost. I mentioned how much of the budget, of the U.S. budget, the Apollo missions took, but we have a situation we just don't have that money anymore, but thankfully industry has come in and provided us with a really wonderful alternate solution. One of the things, too, that we're trying to learn about is, I mentioned a little bit earlier how the younger people in the audience here, all of you that are in elementary school right now, and let me just ask: does any of you younger people want to go to Mars someday? Can you raise your hand? Yeah. Okay. Excellent. I'm seeing a few. Yep. There you go. You'll be able to, and you'll be able to based on what we learn from the moon. And so NASA has just released in the last few months a new strategy that articulates that. We call it the Moon to Mars strategy, and so it makes a lot of sense to me, and so you can see some of the things here that we're going to learn from the moon. One of them, that's kind of one of my personal favorites, is something called in situ resource utilization. An easier way of thinking about that is living off the land. So, if you were one of the settlers moving west, 150 years ago, imagine how difficult it would have been if you had to take every single thing with you, all of your water, all of your food for your 3-month journey. You couldn't do it, right? people lived off the land as they traveled. And what we want to do is learn that same thing through our moon work. And so we have found, and some of the scientists who are in my institute are the heroes behind this. We've found that there's amazing amount of resources on the moon. So water, for instance, we used to think the moon was an incredibly dry, desolate place. Turns out that's not true. There's these things called permanently shadowed regions on the moon that are craters, mostly towards the poles, the North and South Pole, some of which haven't seen the sun, get this, in about 1 billion years, 1 billion years. So you can imagine how cold they are, and you can imagine that any water that has come in from comets or whatever else, and this is something we're studying, has been there a long time. And we had a mission that was overseen by my center, NASA Ames, in 2009, called LCROSS, which actually slammed an upper stage, a spent upper stage of a rocket into one of these permanently shadowed regions. And then there was a shepherding spacecraft that, before it hit the moon, took spectra, took a look at the stuff that was ejected from that impact, and found, yeah, there's water. There's a lot of water, and in these regions. And so we are right now working on a mission called Viper, that's going to be launching in about a year. Again, watch the news. You will for sure see it. We're very proud of that. And that's going to be a rover that's going to dip into these regions and sample and look for that water. And this is a precursor towards sending astronauts there and actually being able to get water that we can drink. I showed the slide saying they'll find out how hard it is. This is a picture. I know that there's some amateur astronomers, I believe, in the audience, which I'm one of them. This was taken by Brian Day, who Mosen mentioned, at our family ranch in San Benito County, and there was what's called a grazing occultation of Mars. So that little orangish dot that you see there is Mars. And I think the important thing about this picture is showing how much farther Mars is than the moon. Mars takes, under the most favorable conditions, takes 9-ish months to get to, oftentimes longer depending on the orbit you choose. The moon can be as little as 3 days. Something goes wrong on the moon, you have your launch vehicle ready, someone gets really sick, you can bring them back. Not on a Mars trip. That can't happen. And this shows that really in a really good way. So I talked about this, I think, so I'm not going to go into detail. One thing that I didn't touch on is the Lunar Gateway, which is going to be a vehicle that's going to be on the far side of the moon in a very special orbit. That's also going to be teaching us, going to be a scientific tool and teaching us how to do exploration in the future. I want to touch on a little bit here on the economics of space. And so, I've had this question more times than I can count. How do you justify NASA's budget? And it's a perfectly appropriate question. I haven't said this yet. I work for you. You guys pay taxes. That pays my salary. That pays what we do. I work for you. This is part of returning, thank you, returning the value back to you so that you can understand, what we're spending this money on. But another thing is that we've done economic studies of the value of NASA. And I sponsored one of these when I was at NASA headquarters in the 1990s. And in one small program, looking at one subset of companies that had been spawned by NASA's work, it turns out that the value to the economy was between 10 and 15 times, just from those 15 companies, of the entire investment in that program of NASA since the 1960s. through the then 1990s. So, so if anyone tells you, I know I'm amongst fellow NASA geeks, right? You know, but if anyone says NASA's not worth it, tell them it pays back to the economy, big time, big time. Every study that we've ever done shows that, and it does it because of all the cool stuff that we develop, all the new technologies from challenges. You know, I've worked with Alvin Toffler and his associates on this, from challenges that we face that people haven't had to face yet. And that's why, you know, we do an economic impact report every year. You know, and in summary, you know, we contribute to our nation's economic effectiveness, and I don't think that I need to convince too many people in this audience. We do develop a ton of different technologies that are used very broadly. I'm going to talk about one or two of those in a few slides. You know, ranging from spin-offs that create virtual worlds to robots. There's some really cool robots that we've developed for the space station that float around in zero G that have a lot of positive spin-offs, et cetera. You know, and so you can just see how many different categories there are of these spin-offs. So it's something that I'm really proud of, that I really do feel that it's cool stuff to start with, you know, to go to the moon, to go to these other places and return knowledge, but then we're also giving back to all of you who fund this, and I'm proud of that. I want to talk about one in particular that I was sharing with Mohsen earlier before that we started. That gentleman there is my father, passed away a few years ago. He and my mom met at what was then NACA. There wasn't a NASA yet, in 1948. He is the guy that proved that it's possible, that it was possible to navigate to the moon through something that's called Schmidt-Coleman filtering. And obviously I'm pretty proud of that, but it's something that is now used in millions of different devices that use GPS, that you use. And so this is something that, you know, I'm sure he didn't have this thought when he was doing this in 1958, 1959, but it's one example of something that's just really exploded into something that's of common use. I think that another thing is that we like to do here is employ cutting-edge IT, and so I'll go back to the Mars exploration rovers, Spirit and Opportunity, which a lot of you probably remember. They were launched in the early 2000s and were phenomenally successful. Opportunity just ceased operations just a small handful of years ago. There's a movie called Goodnight Oppie. I haven't seen it yet, but I hear it's just very emotional and just a fantastic movie. The last message there you can see in the lower right was, "My battery is low and it's getting dark." The spacecraft sent that message before it finally died. But one of the cool things, this is something that we contributed at NASA Ames. This was mostly a JPL mission from Pasadena, California, was a way of intelligently navigating, you know, and again, this is 20 years ago, so it was a little bit more challenging then with the computers that were on board, intelligently navigating around the moon. You know, why did we have to do that? You know, why couldn't we just operate it with a joystick control? Well, Mars is a long ways away, you know, and it takes a long time for the light signals or radio signals to go back and forth between the Earth and Mars. Depending on where it is in its orbit, it can be ranged from a few minutes to a half an hour. So we needed to give these rovers a little bit of intelligence. And so that was kind of the start of that. And it's advanced quite a bit since then. We were also, this is something that my institute is quite interested in, is augmented reality and virtual reality. And when you think about it, you know, when an astronaut is on the moon, you know, they need help finding the cool rocks and stuff. You know, they were trained very well, you know, by the geologists, one of them being Jack Schmidt, who I mentioned earlier. But imagine if they have tools that could take a spectrum of all these rocks out there and say, oh, you got to go for that one, right? We have the tools to do that right now. And we are moving forward on that. And that, to me, is just so exciting. So the astronauts of the later Artemis missions are going to have heads-up displays, you know, that will identify cool things that they can go and check out. I'll just touch briefly on my institute. My institute is a virtual institute. So one of the things that I'm proud of as well with it is that we learned all the stuff that everyone else learned when the pandemic hit. We were actually doing that 10 years earlier or so with virtual meetings. And so we have teams, our scientists aren't, for the most part, at NASA Ames. They're all over the country, and like I mentioned, all over the world through our international partnerships. We have a mission ranging from groundbreaking research to developing these IT techniques and to training the next generation, which was really, really important when we started the Institute. It started back in 2008, 2009, and there had been a whole generation that had been basically skipped of people that hadn't been trained. And so one of our biggest jobs was to develop a bunch of young people and get them interested and get them trained, get their PhDs. And there are so many that I've become friends with now that our institute has helped out in their respective journeys, who are now professors and leading research programs. And I couldn't be prouder of that. So this is basically what I was just talking about. We do a lot of things to help that forward. One of the most important things too, you know, and this really hit me, you know, with the George Floyd murder, is that we have to do something to you know, very actively to change things and create opportunities for everyone. We can't limit this to the people who have had these opportunities in the past. And so we're very, very actively, my institute as well as other organizations, pursuing this. What we talk about, and this is something the Biden administration says, is that Artemis 3 will land the first woman and the first person of color on the moon. And I think that's really cool and something we should have done a long time ago, but at least we're doing it now. So I'm going to talk about a few other cool things, and Mohsen, how much time do I have? 9 minutes. Okay, 9 minutes. Okay, very, very good. You probably saw, was it this last week? No, weekend before, that OSIRIS-REx returned a sample from the asteroid Bennu. I mean, wasn't that incredibly cool, that sample container landing there? Pretty freaking awesome that we now have an asteroid sample that we're gonna, and this is gonna teach us about the origin of the solar system and so many other things. Chandrayaan-3 I already talked about. I'm gonna skip that. One thing, this really hit me. So Mohsen mentioned that I was one of the team that helped start the science of astrobiology a number of years ago, about 25 years ago right now. What I'll talk about in a second, was something we could only imagine back then. What the James Webb Space Telescope, that became operational now a couple of years ago or so, has done is taken the first spectrum of a planet's atmosphere that's orbiting another star. And to me, I remember the woman who first presented this, who's a friend, Natalie Battaglia at UC Santa Cruz. My jaw just dropped. I thought, oh my gosh, because this is a fairly typical looking sort of atmospheric spectrum, but what we might be able to see as we examine more and more of these exoplanets, we call them, we might be able to see atmospheres that say, this atmosphere only exists because there's life on this planet. And what's more, some people speculate that there might be techno-signatures out there, so that not only will we be pointing towards life, but we'll be pointing towards intelligent life. So we might, at least indirectly, identify intelligent life on other worlds in a handful of years. And if that isn't exciting, I don't know what is. We have a mission called Dragonfly to Saturn's moon Titan, which is extremely cool. Titan is an amazing world. It has an atmosphere that's so thick, and the moon is small enough that you could actually, if you put on wings, you could fly. You would be strong enough, humans would be strong enough to fly. And there's a drone that's going to be going there and taking a look. It has lakes, it has rivers, but they aren't water. They're liquid methane. And it's just absolutely wild. We have the Europa Clipper that's going to look at Jupiter's moon, Europa, that's launching next year. We have the Parker Solar Probe that I was just reading just before I drove over here. It just completed its last close bypass of the sun. It was 20 times closer to the sun than we are here. I mean, imagine the heat there, so there were some brilliant engineers that designed this thing. Our friends in Japan are launching a mission next year, or perhaps the year afterwards, to go to Mars's moon Phobos, take samples and bring that back. We have our European friends have a mission to Mercury that's on its way. And we have the Juno mission that's just returning some amazing images of the planet Jupiter. And one thing I want to point out to the amateur astronomers, if you're here, how many amateur astronomers do we have? Awesome. There's a guy here, Clyde Foster, who's from South Africa, who discovered a spot, and he alerted the Juno team that you can see the Juno image of the spot there, and it's now called Clyde Spot. I love this because I've been an amateur astronomer for close to 50 years myself, and amateurs play a huge role in what we do. I can't let, there are just a few more slides here, Mohsen, so I can't let things go by without mentioning the important work that NASA does exploring our home planet. This is the program that my wife, who, as I mentioned earlier, is an earth scientist, works in. She's a program manager and sponsors investigations around the world, dealing with things as diverse as agriculture, disasters, ecological forecasting. You can see all the different things, and we have a unique vantage point. That like I said, I look up, she looks down. Looking down from the vantage point of space tells us a lot about our home planet that is very difficult or impossible to learn otherwise. And if we could play the movie, we'll just play maybe about a minute of it. Diego, let's see if that works. If not, we can go on. You up there?
Diego, make it work.
It did work earlier. All right. You know what? I'm running out of time, so maybe.
Don't worry about it.
Oh, okay. Yeah. All right. Oh,
For over 50 years, NASA has monitored Earth's land, water, and air. These observations have transformed our understanding of Earth system processes and enabled revolutionary advances in human decision-making capabilities. These data are currently used to mitigate the threat of natural disasters, respond to human health crises, and support global agricultural yields. Additionally, these data are being used to inform global conservation efforts to protect and preserve dwindling biological diversity. But how is this possible? The method central to NASA's Earth-observing technology is called remote sensing. Remote sensing is obtaining information about an object from a distance. NASA's Earth Observing Fleet, a group of NASA satellites that orbit around our planet, is an example of remote sensing technology. These satellites are equipped with many types of sensors that collect data on a breadth of topics using different technologies. Which satellites are useful to a particular need depends on multiple factors. What information do we need? How much detail? How frequently do we need the data? All of these questions are considered when choosing a remote sensing product or developing new sensors and remote sensing techniques. Taking a photograph of an object is analogous to many common examples of remote sensing. For instance, NASA uses imaging tools on the Landsat satellites, which gather comprehensive pictures of global land cover. These satellites carry sensors that measure the wavelengths of radiation reflected and emitted by the Earth's surface. The wavelengths reflected by different materials on Earth make up what we normally call color, including hues beyond what the human eye can see. These satellites can then use the differences in wavelengths to determine the type of material we are observing. For example, healthy vegetation reflects green and infrared wavelengths, whereas water reflects more blue and green. Using this technology, Landsat data allows us to track global grasslands, wildfires, erosion, and the timing of leaf and flower emergence in forests. One specific way remote sensing reflectance and emittance data have been used is to help protect whale populations along the California coastline. While most satellites cannot detect the whales individually, they can assess the color of ocean water and its surface temperature. This information, when combined with our knowledge of whale behavior, can predict when and where these marine denizens are most likely to appear. With these predictions, ships now know which areas to avoid, reducing harmful whale encounters and collisions and enabling us to better conserve their endangered populations. NASA remote sensing data does much more. The International Space Station houses a sensor called JEDI, which is a high-resolution laser measuring the 3D structure of Earth's plant life. Much like sound is used to map the ocean surface with radar, this tool uses light pulses and a technique called LiDAR to measure and map trees. JEDI can precisely measure forest canopy heights, structures, and the features of the land's surface. With this information, we better understand how deforestation contributes to climate change and how habitat loss will affect biodiversity. Currently, NASA is using JEDI data to restore the resilience of dry forests, which have been experiencing severe fires and droughts due to rapid environmental change. With JEDI, forest managers are equipped with the tools needed to address environmental impacts and restore these ecosystems' biodiversity. The International Space Station also hosts the EcoStress Center.
Why don't we, this goes on for several more minutes, but I just wanted to give you a little sample anyway of how important this work is. As I always tell my wife, I love what I do. I think it's extremely cool. What she does is more important, because it's about our life here on this planet. I have just a handful more slides that I want to do to kind of stimulate some questions perhaps afterwards. One of which is a very famous equation of the fundamental equation of SETI, the Search for Extraterrestrial Intelligence, that was developed by Frank Drake, who was a friend of mine. He passed away a couple of years ago, back in the early 1960s. And I think the perspective on this is that back 20 years ago, 30, 40 years ago, we didn't know what any of these numbers were. We now have bounds on those numbers. We've detected thousands of exoplanets, that back when Back when I was a teenager, early 20s, that was kind of the holy grail. And then the first exoplanets were found, and we did a mission at NASA Ames called Kepler that found literally thousands of them. There's another mission called TESS that's finding even more. So we now know that there are worlds in our galaxy, that could be home to life, maybe life of a very different kind than ours, and maybe intelligent life. So I think this is some of the most fascinating work that we are doing when it's combined together in this way. I want to share a couple of resources. I'm just about at the end. Just remember this website, moon.nasa.gov. And this is a great place to go for everything moon, and lots of cool stuff, ranging from science to things to do. And in terms of things to do, in just a few weeks, just 3 weeks actually, on October 21st is something that we started. Actually, Brian Day was the one who started this, called International Observe the Moon Night. We now have hundreds and hundreds of locations, actually thousands, all over the world that all look at the moon and post their findings. And the whole idea is to share with folks like yourselves what an exciting world this is. We're kind of unique on this planet that we have this moon that you can actually look up and see. You can see details on it. Most planets are not like this, and so go to that moon.nasa.gov/observe, or just go to moon.nasa.gov and you can find it easily. And if you forget that, contact Mohsen and I'll give it to you. I want to close with a final couple of slides that I think that the work that we've done has pointed us towards a really great future for humanity. That we're doing things, like I've mentioned several times in this talk, we're doing things in a very different way. We're partnering with other nations towards this exciting future. And we're really on the precipice of establishing ourselves as an interplanetary species. That's going to happen, I hope, in my lifetime, and certainly the lifetime of my daughters. And to me, that's just incredibly exciting. This is my last slide, and this is something that's my most prized possession. And it's something that was done by my grandmother. My grandmother was born in the year 1892. And when she was born, she took horse and buggy to school and to get supplies for the ranch, which is still in our family. And, there were no cars. There were no airplanes. She was 11 years old when, about right around the same age I was when Apollo 11 landed, when the Wright brothers flew. And in her lifetime, she saw the advent of cars, of aviation, of jet travel, and then, not just a handful of years before she passed, people landed on the moon. I have her diary entry from that, and she was a farm woman, and but I just remember her awe in the diary writing about this. And so I think that this, and she did this needlepoint, which, like I say, is something that I just treasure so much. I think that this paints the future. I can imagine if it changed that much, in that amount of time. Imagine where we'll be when some of these young kids who've been through far too much of my talking right now, imagine what it's going to be like when they're my age. I can hardly wait to see. Thank you very much.
That was great.
My pleasure. Yeah.
one of the best, wasn't it? Give him another hand. Thank you.
It's an honor.
Very good, very good.
Thank you.
Very informative, very broad, and very inspiring. I really enjoyed the talk. I hope you did. We will have some more technical questions for some of you during the reception, but we do have about a few minutes for you guys to ask some general questions. Jason, are you here? Okay, I want one more person to go get that mic. Okay. And before we start, I have a person bringing the microphone to you. Would you be happy to give some question? Would you answer some questions?
Oh, yeah, of course. Absolutely.
Okay.
Yeah.
So one curiosity, for those commercial organizations that you're piggybacking off of, what is their goal? Are they trying to pull minerals, or what is their commercial goal in trying to explore?
It's a really good question, and basically the answer is I don't really know. You know, I mean, it's something that they hold because they're commercial companies. These are trade secrets. You know what? You know, I do know some of them are interested in resource extraction to help with future space travel. You know, at least a couple of them are. Beyond that, where's the gold? Where's the thing that's going to really be their return on investment? I don't know. I'm not sure. One of them that I can mention too is that I think of Mexico, for instance, in this way. Mexico has a rover that's going to launch on one of the companies, Astrobotic, on their mission next year, I believe, something like that. Mexico will have a presence on the moon. And that is, to me, amazingly cool. So I think that part of the benefit is providing nations that would otherwise not have a chance to play in this game, give them a chance and have them become a spacefaring nation. So I'm sorry I couldn't answer your question more, though.
Excuse me, may I just ask you to read the words on your grandmother's needlepoint? I can't read it from here.
Oh, the words? Yeah, one small step for a man, one giant leap for mankind.
Oh, I see. Okay.
Yeah.
Thank you.
Sure.
And that's the title of our talk tonight, by the way, is another one, another giant leap.
There's yeah.
What will early moon settlements look like?
That's a really good question, and so her question was, what will early moon settlements look like? And so I think that we're actually studying that right now, and so but we haven't gotten that far yet. And so what we're doing is looking at rovers, that are pressurized and stuff. That's kind of about as far as we've gotten. One of the things that we think about, though, the Earth has this thick atmosphere that protects us from the sun's radiation and from these things called coronal mass ejections, which are really nasty if you're out in space, but if you're on the Earth, no problem. And so the moon, however, doesn't have that atmosphere. And so one of the things that we're thinking about, and it's an excellent question, is putting the settlements under what we call lunar regolith. Basically, it's the soil that's on the moon, which is really different from the soil on Earth, because it's on the moon. It's formed by meteorites just pulverizing, the rocks. So anyway, does that answer your question at all?
Well,
Okay.
actually, excellent question and excellent answer. To go underneath and do that, that's great. Any other question? Oh, Lynn.
Very general. When you refer to worlds, there are planets out there, and the Earth is a planet. But when I hear you say in that other world, what is your definition? I mean, we're not just talking about a planet. At least that's not what
Yeah. So, and I am actually talking about planets. I think about, and so, but I'm doing a broad definition of those. So it's not just the planets that are in our solar system. It's the planets that we've discovered in other solar systems, orbiting other stars, and so I think about, I like to use that word in a way because they are worlds just like the Earth is in a way. I mean, very different. Well, it reminds me of the New Horizons mission, which was the mission to Pluto. And a very dear friend of mine was one of the principal scientists on that. The Pluto's so far away that the data took over a year to get back to Earth. The data rate was that low, right? And so his office, actually, as it turns out, was right across from my wife's office. And she would say, "Oh my gosh, Greg, Dale was like, he's now in his 80s, by the way. He was like a little kid. He saw this image and he ran across, look at this, isn't this cool, right?" And so what this is doing is it's changing these from points of light into real places. It reminds me of another story. One of the investigators that I worked with for the Mars exploration rovers that I talked about, Spirit and Opportunity, after he had been working on this for, he lives up in this area, actually. I think he lives in San Mateo. And Dave DeMarais is his name. And he said, Greg, I know these parts of Mars better than I know San Mateo. Isn't that wild? So that part of Mars had turned into a world for him, just like the Earth is. So that's kind of why I like using that. Yeah, if that makes any sense. Yeah.
But that's true for me too, by the way. I know that part of the Mars better than San Mateo, but that's because I don't know San Mateo.
I have a question. I don't know if you mentioned the name of the individual who founded astrobiology. Was that Bloomberg when you showed his picture? And then one other question or comment. You mentioned, I don't know if you meant Apollo 11 or one of the earlier missions. You said Apollo 13 brought back the rocks, but I thought Apollo 13 didn't land.
Oh, did I say Apollo 13? If I did, I made a mistake.
No,
Apollo
I
13 did not bring back any rocks. It came back, which was darn lucky and good engineering. And in terms of Barry Blumberg, he was one of the founders of the field, and we brought him in. I chaired this workshop called the Astrobiology Roadmap Workshop. We got two Nobelists to come in. He was on a sabbatical at Stanford at the time, and he was so interested in this. He just thought this was the coolest thing, even though his work had been very different, that we brought him in as the founding director of the Astrobiology Institute. So,
wow.
So he was very, very important in the early years of astrobiology. We owe just a huge amount to him.
Let's get two more questions. Go ahead.
Yeah, thank you for a great presentation. I do remember the landing. I watched it on TV in 1969. I was a young kid as well. And thank you for presenting the notion for the settlement on the moon and the technical aspect of it as well. Of course, besides the fact that the escape trajectory from the moon allows us the optimum path to Mars that people want to use that way. And the technical aspect of it is all good, but I do want to ask you a question on the political aspect of it. The colonization of the moon will take us in that area. What do you think of, allowing regulations and working on regulations in that area?
Yeah, an excellent question, and that's one that I get pretty often, actually. And so there is an international space treaty. That was signed quite a few years ago, but that was signed during a very different time, and so there were no commercial lunar companies back then that were interested in resource extraction, and we have to be careful with the word colonization. It has, for good reason, it has a very bad rap. now. I think that we have to do things in a sensitive way that protects everyone's interests. And so it's a balance, because we want these commercial companies there because they're going to be what brings us to the rest of the solar system, that we couldn't afford it otherwise. On the other hand, we want to do it in a measured way. And so there has been talk, of having negotiations. There's a UN group based in Graz, Austria, that I've dealt with from time to time, a Committee on Peaceful Uses of Outer Space, which is also dealing with this. I think that what's going to make it come to a head is when these commercial companies actually do landings. And so I know that's a long answer with very little substance, but it's a good question. It's something we're thinking about. We just don't have an answer yet.
One more question, way back there.
Okay.
Okay, go ahead.
Yeah. I have a question that, what is your job doing, and what is this institute doing about? Like, what's the actually project they're doing? And
Yeah.
Another question is how to get into NASA.
Are you a student? Yeah. What are you studying?
I want to study
Awesome. We need people like you. Our institute focuses on lunar science, also asteroid science, and we're really based at the intersection of science and human exploration. So we address science questions that are helpful to human exploration, and also science that is enabled by human exploration. The virtual, yeah. So we are an institute without walls, as one of the NASA administrators once said. And so what that means is, rather than various institutes like the Monterey Bay Aquarium Research Institute, for instance, down in Moss Landing, it's everyone's in a building. We're everywhere in the U.S. We have about 250 to 300 researchers, depending on exactly when, that are all over the United States that we fund. We can't fund foreign partners, but we are partnering with them. And so if you include them, we have close to 1,000 scientists all over the world. And so virtual, what that means is that they're not all in one place, that we connect, with Teams and Zoom, and all of these ways to share insights and data. Okay.
Thank you so much. We can have other questions outside.
Okay.
Oh, do you want to have one more?
He's had his hand up for a
Go
while.
ahead, ask it.
Yes. My institute, this was so cool. This was just so cool. So there was a meeting ahead of that in Washington, D.C., ahead of that anniversary. The Washington Monument, right? It turns out that it's a little bit taller than a Saturn V rocket. And the Air and Space Museum, based in Washington, did this incredible projection system, and they put a life-size image of the Saturn V on the Washington Monument. And so I went there one night, and you could see it. It was amazing. And then they had a really special program on July 20th. I should mention, our annual conference is always the week of July 20th, so that we always get to celebrate the anniversary. And I'm sorry, your other question again?
That was the only question I had.
Okay, all right. Very
Okay,
good.
thank you so much.
All right, thank you.
If you have more questions, of course, you will be available upstairs
Sure,
for a few minutes.
Few minutes, yeah.
Okay. There's food up there. At 9:15, we're going to be in the observatory. Thank you for coming. It was a pleasure. One more hand. Come on.
Thank you.
Thank
That
you.
was fun.
Oh, thank you so much. It was
Sure.
awesome. You have
Sure.
to do it again.